So today I'm going to be explaining about fuzzy clustering. What is fuzzy clustering? Fuzzy clustering is a versatile machine learning technique that allows data points to be assigned to numerous clusters at once. That means data points can be assigned to different clusters at random, making it excellent for data sets with ambiguous boundaries. Traditional clustering approaches, such as k-means, allocate every data point only to a single cluster. But however, here in fuzzy clustering, we are introducing partial membership, which allows a point to belong to many clusters to variable degrees. This is important in situations such as medical imaging, which helps in identifying overlapping tissues in MRI scans, customer segmentations, where we can segregate customers into budget shoppers or luxury shoppers, and in bioinformatics, where we analyze genes involved in multiple biological pathways. So, how fuzzy clustering works? So, firstly, fuzzy clustering has an algorithm called as fuzzy C-means algorithm. So, the fuzzy C-means algorithm is uses an objective function to calculate cluster centers and membership grades. So in the mathematical foundation, the FCM minimizes into j is equals to summation of I is equals to 1 to c, k is equals to 1 to n, mu ik power m, and the distance between xk minus vi whole square, where mu ik is the membership of point k, which is present in a particular cluster I, where vi is the center of cluster I, and m is the fuzziness parameter. M is greater than 1, but most usually we take it as 2, and C is the number of clusters. And coming to the algorithm steps, first we initially assign random membership grades. So you can also call them as membership probabilities to a cluster and to a first cluster and a second cluster. So such that the probabilities add up to 1. So this is the formula for computing cluster centers, where it is nothing but summation of k is equals to 1 to n mu I k m x k divided by summation of k is equals to 1 to n mu I k power m. And after this, we use this formula to update the memberships, which is nothing but 1 by summation of j is equals to 1 to c. So here the j value changes into xk minus vi by xk minus vj whole power 2 by m minus 1. So like just knowing the formulas doesn't do anything. So let us get to an example. So in this numerical example, we are clustering 4 points into 2 clusters where C is equals to 2, and let us take M is equals to 2. See, as I told you, here in this example, the clusters probabilities always add up to 1. So here we have data points 2, 2, 3, 3, 2, 7, 8, 8, 7. And we have 2 clusters, namely cluster 1 and 2, which have the probabilities of 0 0.8, 0 0.7, 0 0.3, 0.2, 0.2, 0.3, 0.7, 0.8. So the first is nothing but we're finding the cluster centroids. So using this formula, how we do means first we take in cluster 1, we take the first point 0.8 into we multiply it with 2 plus 0.7, we multiply it with 3 plus 0.3, we multiply it with 7, and 0.2 we multiply it with 8, divided by 0.8 square by 0.7 square, 0.3 square, 0.2 square. So we get approximate 2.67. So after this, we do the same thing, but we multiply 0.8 with this second data point 3, 0.7 with 2, 0.3 with 8, and 0.2 with 7. So here in cluster 1, we did this equation twice. So we do the same thing in cluster 2, so as we get 4 centroids or centers, whatever you call it, 2.67, 2.2, 2.33, 7.33, and 7.67. So updating memberships. So for updating memberships, we use the formula. We use this formula where first, before that, we find the distances between the data points and the centroids. You can use any formula. It can be either distance formula or something. And after that, we substitute them in this formula and we get the membership. We get the membership points, membership scores or membership points. So like for example, this has been simplified over here. Mu11 is equals to 1 by 1 plus 0.75 is one thing, 0.75 by by 5.66 whole square, which is approximately equals to 0.97. So we do the same for mu12, mu21, mu22, mu23, mu31, mu32, mu41, mu42, and we get 8 membership points. So when do we stop it? There are two reasons when we will stop. There are there are two there are only two conditions where we stop this. When the number of iterations has either completed, or the difference between the two membership points, adjacent membership points, is less than the certain threshold. So that is the time when we stop it. Now let us get to the code. So this is the code for implementing fuzzy C-means algorithm. So first we import the data sets, the NumPy and Matplotlib as usual. Then we define a function named fuzzy C-means, where we input a 2D array, where C mentions the number of clusters, M is the fuzziness parameter, max iterations we kept it as 100, epsilon is nothing but the threshold, which we kept it as 0.01. After this, we initialize n is equals to len of data, which is nothing but the number of data points. np.rand.nc is nothing but we randomly initialize memberships, and we normalize memberships over here. After this, coming to the for loop. In the for loop, we track membership changes across iterations, and we even store the past membership values so that we can get convergence check. Convergence is nothing but the checking for epsilon, like if the values are less than the certain threshold. So that is nothing but convergence over here. So after this, here we update the membership matrix using a for loop, and we handle potential divisions by zero so as that we can handle them properly. And this part saves the current state, like current iterations. After that, we check for convergence check here. So it's nothing but we measure the magnitude of changes in the membership matrix, and it will be stopped when epsilon is below some certain threshold. Here we are taking some example data. So like after that, we are implementing the fuzzy C-means over here, and we are printing the results. Finally, we visualize the results in a graph. We are visualizing the results in a graph. So like here we have got the output like showing that we have converged after 4 iterations. So like the epsilon value has fallen, the difference has fallen below 0.01, which was nothing but the epsilon value. And we got the membership matrix finally. And this is the graph. So basically this is the code. And now let us get to the advantages and limitations of fuzzy C-means or fuzzy clustering, whatever you call it. So the advantages are it handles ambiguous or overlapping data. It provides nuanced insights through membership grades. It is robust to noise and outliers. Limitations are the convergence is much lower than k-means. So it requires a predefined cluster count, like how many clusters you're using. And it is sensitive to initial membership values. Coming to conclusion, this fuzzy clustering revolutionizes the analysis of intricate datasets where strict boundaries are not suitable. The fuzzy C-means algorithm, featuring its membership degrees and iterative refinement, provides a versatility that conventional techniques do not possess. By using the code examples provided earlier, you can investigate fuzzy clustering in practical situations such as customer segmentation or medical imaging. So this is all about fuzzy clustering. I hope you liked it. So thank you.